Okay, these last few problems are called definite integrals. If you watch the first two videos we made, for example, almost all these integrals, by the time you get done, you have variables left. These are expressions. Think about a definite integral. So those are all called indefinite integrals. This is called definite. When you take a definite integral, when you get done, your answer is actually just a number. 5, 1/2, -17. Whatever, it's just going to be a number. Now the way you can tell a definite integral, let me just look at, let's just do these. Probably easiest to explain as we go. Written like this, that would be an indefinite integral. And if I were to integrate this, let me just put it over here. It's pretty straightforward, right? It would just be 3x plus c. When you take an indefinite integral, you have variables in it, almost always, most of the time. And plus you have this integration constant. You have to have the integration constant. So how do you tell if we're taking a definite integral? It's very easy. They stick these numbers at the bottom and top of our integral sign. That means it's a definite integral. So what you do is you go ahead and you integrate like normal. So the integral of 3 to dx is 3x. But instead of writing the plus c, the integration constant, what I like to do is you draw a vertical line, and this low number here I put at the bottom, and this number I put at the top. And what this means is, whatever your expression is here, I'm going to substitute this top number in for x. So you take your answer, this expression, and you plug 1 in for x, and then it's always subtraction, and then you plug in the lower number in for x. So it's almost like the top subtract the bottom. And by the top, I'm saying whatever number's in the top, you plug that in for x, and you take that, subtract, once you plug in this number for x. So here's the top, subtract 3 times x. So this translates into that. And as you do a few of these, you'll find this not very hard. So this is 3 minus, this is -6, so if I subtract -6, that's your answer. It's a number. Let's just do a couple more. I think the easiest way to pick this up is just to do them because it's really not a very hard concept. So now 15, we're going from 1 to 4. 5 minus 2x with respect to x. So now we have two terms in here. So what you do is you go ahead and you do your integral, and you integrate first, and then at the very end you'll just tack on this vertical line with the numbers. So you integrate first, then you go involve these numbers. So if I would integrate this, I can integrate the 5 first. 5x minus 2. Now, if I integrate this, I have to add 1. And then the exponent goes on the bottom. Let me simplify this sum before we evaluate it here. So it's going to be 5x, these 2's cancel out, minus x squared All right, so now we've integrated it. Now I want to evaluate it. So once again, you take the whole expression and you plug in 4 for all the x's. So the 4 goes here, 5 times x, 5 times 4, minus x squared. So I put in 4 for x, it's 4 squared. So this is the expression with 4 replacing x. Then it's always subtract. And now I'm going to rewrite the expression, except in place of x, I'm going to put a 1. So 5 times 1 minus x squared, but I'm putting in a 1 for x. And now it's just some pretty straightforward math. This is 20 minus 16 minus 5 minus 1, 4 minus, turns out the answer to 15 is 0. All right, let's do the rest of these. Hopefully you're picking this up. From 1 to 4, number 16 of 2, square root of x dx. So I know this is a definite integral, but the first thing I have to do is integrate. So now I'm thinking to myself, okay, square root of x, I know what to do with that. Turn it into a rational exponent. Now I'm ready to take the derivative, put the 2, so x, and then you add 1 to this, so adding 1 to 1/2 becomes 3/2, and then that exponent goes on the bottom. But I don't put plus c, instead I just put my vertical bar with my numbers. I should probably simplify this. I think if you move this to the top, this ends up being 4/3 x to the 3/2 from 1 to 4. So this math might get a little messy. We'll see. Let me just, the 4/3, I can move way out front. So I put in 4 for x. I have 4 to the 3/2 minus 1 to the 3/2. Let's figure out what these are. Let's go off to the side here. If I'm going to evaluate this, the easiest way most of the time is just to convert it back to a radical. Seems crazy, but 4 to the 3/2 is square root of 4. I'll put the 3 on the outside. Square root of 4 is 2. 2 cubed is 8. This whole number equals 8. 1 to the 3/2 is just 1. So really, what I have is 8 minus 1, which is 7. Looks like 28 over 3. Up. I just saw a mistake in my key. I called this 17. So I'll fix the key, but this is correct. So now we've got like a couple more to do. So on the review is correct. The key, I saw a mistake, but I'll fix that. So 17 is from -1 to 0, -3x to the 5th, minus 3x squared, plus 2x, plus 5, all with respect to x. Now looking at the integral part of it, I think it's pretty straightforward. These are 4 separate terms. Looks like they're all, well, I say that, but then I realize this one. These were all going to follow the power rule, but not this one. That looks like something that'd be in a log. So this first one, x to the 6, 6 on the bottom, minus 3, and then x cubed, 3 on the bottom. So here, the integral, oh yeah, integral of, no, I'm mistaken. Integral of x, see, maybe I'm getting confused. I must be getting tired. It's not natural log, it's just this. And now this whole thing, now it's sort of messy. I guess let's simplify this. This is like negative 1/2 x to the 6th minus x to the 3rd plus x squared plus 5x. So what I have to do is I have to plug in 0 for all my x's. Now if you look, every term has an x. So this whole thing is just going to be 0, but be careful because it's still going to be 0 minus. Now I'm going to plug in minus 1 into all my x's. Minus 1 to the 6th power is just going to be 1. So this is 1/2 minus x cubed, negative 1 cubed is actually negative 1. X squared, if I plug in minus 1 for x, minus 1 squared is just 1. Now minus 1 times 5 is minus 5. So it's not hard math. You just have to be careful, especially with your signs. So basically, negative 1 plus 1 plus 1 minus 5. So this is 2 minus 5 is minus 3. Looks like minus 3/2, right? Because this is minus 3, not minus 3/2. Minus 3 plus a negative 1/2, which ends up being negative 7/2. But then it's all said and done, 7/2. And the last one, 18, although there are 19 in this first review, the 19th one was sort of a mistake. It doesn't really work. So I'm not going to do 19. So this will be my last one. Minus 3 to 0 of 2x plus 6 raised to the 4th power with respect to x. This, to integrate this, I need to use substitution. All right, what we practiced a little bit ago. I don't want to multiply 4 of these parentheses together. So let's integrate with substitution, and then we can plug in our numbers. So let's let u be what is inside the parentheses. Then du dx would be just 2. So dx would be 1/2 du. So now 2x plus 6 is u to the 4th times 1/2 du. If I pull the 1/2 out front, so now it's just the power rule. So it's going to take this integral. U to the 4th means u to the 5th over 5. Let me not put the numbers in here yet, because these numbers are for x and not for u. I'll put them in a minute. Let's switch back to x. So this is 2x plus 6 raised to the 5th power. Now I'll put in my minus 3 and 0. So now, once again, I plug in 0 for my x's. Let's move the 1/10 out front. So 0 for here. So 2 times 0 is 0. So it ends up going to be raised to the 5th power minus, when I plug in minus 3 in for this, raised to the 5th power so 0 plus 6, this is just 6 to the 5th, minus 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. So it's really just 6 to the 5th over 10, which, if someone wants to try and simplify it, ends up being this, or as a decimal. All right, so that is what we've learned so far about integration. We learned the basic rules, how to integrate indefinite integrals, and then we learned sometimes you have to use the substitution. And then toward the end, we actually started looking at definite integrals where your answer is a number. All right, hope that helps you get ready for the test.